Very good morning, students. And once again, I welcome you all for the digital lecture of Science and Technology. Dear students, in the last lecture, we had already started with a new lesson, lesson number 5, towards green energy. So today we are going to continue with the remaining part of the lesson. We had studied about the generation of electrical energy, how the electricity is generated. Here is the flow chart showing the generation of electrical energy. We had studied that the electric power plants are based on the principle of electromagnetic induction, and this principle was invented by the famous Michael Faraday. Now, according to this principle, whenever a magnetic field around a conductor changes, a potential difference is generated across the conductor. So, whenever the magnetic field around a conductor is changed, it can be changed in two ways. First one is keeping the conductor stationary and the magnet rotates. And in the second one, it's just opposite. The magnet is stationary and the field around the conductor changes. So this is how the electrical energy is generated. Now, this flow chart explains. Now, in this flow chart, the sequence of the plant is shown. Now, first, the turbine is used to rotate the magnet in the generator, and turbine is rotated with the help of a flow of liquid or gas which falls on the blades of the turbine, right? Now, due to this, the turbine starts rotating, and when the turbine starts rotating, the kinetic energy is produced, and this kinetic energy starts running the generator, right? And then the electric generator, it starts rotating, and then the electrical energy is generated. So this is a very general way of producing or generating the electrical energy. Now, on the basis of the source which is used to rotate the turbine, there are different power plants. The very first power plant is thermal electric power station. Now here the thermal power means the steam energy is used to rotate the turbine. Now in this thermal energy based electric power station, the coal is burnt. So the fuel is the coal, and then heat energy is given to the water, due to which the water is heated in a big boiler, right? Now here water is converted into steam under very high temperature and high pressure. Now this steam, which is under very high temperature and pressure, it goes into the turbine, it falls on the blades of the turbine, and the turbine starts rotating, right? So the steam energy is used to rotate the turbines, and then due to the turbine, the generator which is connected to the turbine starts generating the electrical energy, and from the turbine the steam is allowed to condense, and again this water is sent back into the boiler. So this cycle goes on. And below that I had shown you the ray diagram. The chemical energy which is present in the coal is converted into thermal energy or steam. This thermal energy, steam, has the kinetic energy. This kinetic energy rotates the turbine, and in turn turbine starts with the generator, and the generator generates the electrical energy. So this is all about the thermal electric power station. This is just the revision. Now the second one is power plant based on nuclear energy. Now here the steam turbine is used to rotate the generator, but here the energy is released from the nuclear fission of the elements like uranium or plutonium, which generate the steam at a very high temperature and pressure. In the previous one, the thermal or the steam was used from the coal. Now here also the steam is only being used to rotate the turbine, but the steam is heated by the energy which is released by the fission of the atoms of uranium or plutonium. Right? Now this energy in the steam, in the kinetic form, it starts rotating the turbine. Okay. Then in turn this turbine, it drives the generator, and then in the last step the generator starts producing the electricity. Right? This is how the nuclear power plant works. Here the fuel used is uranium or plutonium. Right? Then again the steam which rotates the turbine, that is again condensed, and this is again sent to convert into steam. Right? This is same in both. Here also steam is allowed to condense, and then it turns into water, and then again water is sent in the previous step. Now the energy transformation in nuclear power plant, this is very simple as I had shown you. Now here the nuclear energy, we had taken the uranium or plutonium, right, and the fission of the nucleus of the atoms is done. So the nuclear energy is converted into the thermal energy or into the steam, right. Then the kinetic energy present in the steam, it rotates the turbine, right. So turbine starts moving, and finally the kinetic energy of turbine is converted into electrical energy. So this is the step by step energy transformation in nuclear power plant. How at different steps the energy is transformed from one form to another. Okay, this is the diagrammatic or the ray presentation of the nuclear power plant. Now, can you tell, there is a question, how does nuclear fission takes place? Fission means breaking up. Fusion means combining. So, nuclear fission means breaking up of nucleus. Now, we know that atom has a nucleus in which the proton and the neutrons are present. So nuclear fission means this nucleus breaks up into proton and neutron. It can be either due to natural radiations, or it can be due to the bombardment of other neutrons. Now when this fission takes place, when this nucleus breaks up, a large amount of energy is liberated, which is called as nuclear energy or atomic energy. So this is called as nuclear fission. Now we will see what nuclear fission or the chain reaction is. Now in nuclear fission, the neutron is bombarded on uranium-235. Okay. Now this uranium-235 is an radioactive element. When the neutron is bombarded over this uranium-235, it absorbs the neutron and converts into its isotope, that is uranium-236. Right? So when a neutron is absorbed in uranium-235, it converts into its isotope, that is uranium-236. Now this uranium-236 is extremely unstable. it cannot remain for a long period of time. As soon as it is formed, it breaks up into barium and krypton, right? Because it is unstable, so it immediately breaks up into barium and krypton, and in this the three neutrons are released. You can see in the center three neutrons are released, and on the sides barium and krypton. So these are the five products. Uranium 236 breaks up into barium and krypton, and three neutrons are released. And in this, a large amount of energy is also released. Now, these three neutrons, they again bombard a new atom of uranium 235. Okay. So, this uranium 235 again absorbs the neutron and forms uranium 236. Again, this uranium 236, as it is very unstable, it converts into barium and krypton, and again three neutrons are released. Energy is released. Again, these three neutrons, they bombard a new atom of 235 uranium. So this continues. Once the reaction starts, it forms a long chain. That is the reason why it is called as chain reaction. Now, this energy which is continuously releasing, right? So, this results in the production of the thermal energy which is used for the production of electrical energy. So, this is all about the nuclear fission or the chain reaction. Now, let's see how this nuclear power plant looks like. You can see the schematic presentation of nuclear power plant. There is a nuclear reactor where the nuclear fission reaction takes place. It is connected to the boiler. See, the further three steps are same: boiler, turbine and generator. Only the difference is how the steam is produced to convert the water into steam to run the turbine, right? So here the nuclear reactor is used in which the nuclear fission takes place. Neutrons are bombarded over the uranium 235. It converts into isotope of uranium 235, that is uranium 235. It breaks up into krypton and barium, and three neutrons are released. So in this nuclear reactor, the nuclear atomic energy is released, which heats the water and converts it into steam. So this steam then in turn with the kinetic energy rotates the turbine. Now again the condensation of steam takes place, and this steam after condensation goes back into the nuclear reactor. The turbine in turn rotates the generator, and then the electrical energy is produced. So this is how the electrical energy is generated in the nuclear power plant. Now, as we had seen that in this nuclear power plant, the fossil fuel like coal is not used, right? So there is no question of air pollution, right? In the earlier one, we had seen that because the coal was used as a fuel, so it gives rise to the air pollution by giving out harmful gases. But here, the conventional fuel is not used. Coal is not used. So, the air pollution also does not take place. And if sufficient amount of nuclear fuel is available, then this can go on continuously giving a very good source of electrical energy. But as I always say, that every coin has two sides, right? So it is not that here the problems are not there with the power plant, nuclear power plant. No. Okay, the air pollution is not taking place, but there are other problems which are associated with the nuclear power generation. Now, the very first problem is harmful radiations. As I said, uranium is a radioactive element, and students, if you remember, we had studied in the previous class that radioactive pollutants are the worst pollutants. Why? Remember? Because first thing is that they remain in the atmosphere for a very long period of time, and second is they bring about changes in the genetic material. They bring about mutations in the chromosomes, and thus they are very hazardous. They had adverse effect not only on the present generation but on the coming generations, because genetic materials are transported from one generation to another. So these mutations, these changes which takes place, they are carried on to the next many generations. So this is the worst problem of this nuclear power plant. And as we are using the radioactive element, so the fuel used is radioactive, which emits very harmful radiations, right? And the waste is called as the nuclear waste. Now, how to dispose of this nuclear waste so that it does not have adverse effect on the environment or in the sea, right? So it is a big challenge for the scientists to dispose of this nuclear waste. Then the second problem is fatal accidents. You might be, if you are reading the newspaper, hearing the news, many a times you hear that in the nuclear power plant an accident has taken place and the radiations are being given out from the plants. So this nuclear power plant, if meets with an accident, it's very fatal. And because this accident results in the harmful radioactive radiations, and as I said that these radiations are very harmful because they have make changes in the chromosomes. They bring about changes in the genetic material. So this is the, you can say, the other side of the nuclear power plant. Otherwise, it has a very strong benefit, very good benefit, that it, once the chain reaction starts, it goes on continuously and produces a larger amount of electricity. Students, with this we come towards the end of the lecture. Students, right from the beginning, we all teachers are humbly requesting you that please keep on completing your notebooks simultaneously. So, whichever lessons we had completed, please complete the textual exercise as well as whatever questions are discussed in the lecture. Please keep completing your books, because in the next month most probably you will be having your first online assessment. So whatever lessons I have taught you till now will be there for the first online assessment. Don't worry, before that I am definitely going to discuss with you which lessons or what portion is going to come in the online assessment. So you just keep completing your notebooks, and please take care of yourself, your family, your friends, your neighbors, and your relatives. Please do not roam outside. Please do not go out of your house without any emergency. So, students, please take care and stay home, stay safe. Thank you, students. See you next time.